I am Alison Duvall, and I am a geomorphologist. We as humans, we live on the surface of the Earth, we interact on the surface of the Earth, and geomorphology tries to better understand how it changes with time and how it formed in the first place. It's a mouthful, but what I really call myself among geoscientists is I'm a tectonic geomorphologist, which means in particular, I study how the surface of the Earth responds to tectonic activity. This planet is made up of tectonic plates, and those plates are moving around ever so slowly by human perceptions, but over time, as they move around, they do things like create the Himalayan mountains or open up to form a really deep basin. And so I'm really interested in the ways that tectonics shape the surface of the Earth. I'm also very interested in how the geomorphic processes that alter the surface of the Earth can be inverted to back out information about tectonics. So I'm interested in both the geomorphology for the sake of understanding how surface processes works, but I'm also really interested in answering big tectonic questions. So I'm really interested in faults and mountain building and how rivers and landslides respond to those things. So hence, earthquake-driven landslides, for example, is something that I really focus on. Or I want to think about how a stream might steepen or bend in response to a fault that it runs over. I'm interested in that because I want to better understand the physics of how rivers work, but also because I want to be able to look at an image anywhere on Earth of what a river is doing and be able to pull out from that what the fault underneath might be doing. Because it's very easy for us to see the surface of the Earth these days, and not nearly as easy for us to understand what's happening in the subsurface with a fault, for example. LiDAR is a technology that we use to get really high resolution mapping of the surface of the Earth. And the thing about LiDAR that's so special is, one, it's really high resolution, but two, it allows us to remove the trees from our image. That is incredibly important. Without that technology, we're really flying blind. So if you were to look at a Google Earth image where the trees are and a bare Earth LiDAR image right next to it, you would be astounded at how many places, including places where people are living and recreating and schools exist, when you look beneath those trees, there's a ton of landslides underneath there. Or maybe even faults that we didn't know had cut through the surface. So LiDAR has absolutely, I can't emphasize this enough, it has absolutely revolutionized our ability to map landslides in the Pacific Northwest, and we just could not do what we do without it. So we have faults of many different stripes, which produce earthquakes. We have volcanoes, and we have lots of steep topography, so lots of mountains around, and lots of high precipitation. So all of these things together means that we have a very dynamic, we live in a very dynamic part of the Earth, and it's a great place for people like me who study all of those kinds of processes from the tectonic to the surface.